Students, welcome to my YouTube channel. I am Dr. Himanshu Sarkar. Already I had given the introductory lecture yesterday. I think all of you have observed it. Today I am starting a very easy topic, that is the heat transfer by various systems, various methods. All you know how the heat transfer. All you know the heat transfer in normally there are three ways. One is called conduction, another is called convection, another is called radiation. First, what is the conduction of heat? Conduction means what? Transfer of heat, or flow of heat from high temperature point to low temperature point, but here the material particles are not transferred. Actually, what is heat? Or you know, the heat is a form of energy. Heat as a form of, it is a form of energy. Heat is a form of energy. Actually, suppose I consider a metallic rod. This is a metallic rod. One point of this rod is kept in oven. That is oven. Oven means high temperature. So this temperature, this point A is at high temperature compared to that of the point B. So how the heat flow? Heat is flowing from point A towards point B. Actually heat heat flow from high temperature to low temperature. Suppose this temperature theta 1, this temperature theta 2. Theta 1 is greater than theta 2. Theta 1 is the temperature, is the higher temperature, and theta 2 is the lower temperature. Alright? Theta 1 is a higher temperature, theta 2 is the lower temperature. So in this method, what is happening? Heat is flowing from point A to point B. But this is a system called conduction of heat. In conduction, what is happening? Only heat energy flowing from point A to point B. I think all of you clear? From point A to point B, but without any material particle transfer. That is the basic concept of the conduction of heat. I think all you know regarding the convection of heat. In convection, what happens? In case of the convection, of heat, all you are familiar with the how water is warmed if the container is kept in an oven. Suppose this is the container, this is the water, this is the oven. Then what happens? This part of the water is heated up. All you know, with rising temperature, density falls. Okay, with rise in temperature, density falls. So this water is lower density. So what will happen? This water, lower density water moves up. Lower density water moves up. Similarly, this temperature of this water, upper portion is cold compared to this, then what will happen? Density is higher. Then what will happen? That is, this water moves down. So this water moves up, this water moves down. This system is called convection current. I think all of you clear. This is called convection current. So as a result, ultimately a stage will come, whole of the water system will be warmed up. In this thing, this is called convection. Actually, what is the basic difference between the conduction and the convection? In conduction, molecules doesn't move from one part to the another part in case of the conduction. But in case of convection, the molecules move. Here this molecule moves to here, here this molecule moves to here. There is a basic difference between the conduction and the convection. And one thing, conduction and convection both needs medium. Clear? Now, another form of the mode of the heat transfer, all you know, that is called the radiation. All you are familiar with the radiation. Radiation. In case of radiation, what happens? Suppose we get heat energy from the sun. This needs no medium. This needs no medium. So, conduction and convection needs medium, but radiation does not need any medium. So, now let me start with the basic physics of the conduction of heat. Slowly I will discuss conduction, convection, radiation step by step. Okay. Now, suppose again and move to the conduction. This is the rod. This temperature theta 1, this temperature theta 2, temperature theta 1 is greater than temperature theta 2. So what will happen? Heat flow from the high temperature to low temperature. So heat flow like this direction. That is the heat flow direction. I write down the heat flow as a Q. Q is the, write down suppose amount of heat flow. Actually, Q is proportional to, actually heat flow depends on the temperature difference. So Q proportional to obviously theta 1 minus theta 2. Now, if I consider A is the area of the cross section, then Q proportional to the A. Q proportional to the A. What is A? There is the area of cross section. Then, with rising time, if time increases, heat flow also increases. That is Q proportional to T, where A is the area, T is the time. And also, I will define a quantity called the thickness. Here you don't consider thickness means this thickness. Actually, thickness means what? The distance between the two temperature difference zone. Here is temperature theta 1, here is temperature theta 2. This distance is x. So x is called what? X is called the thickness. So I consider Q also inversely proportional to x, where x is the thickness. So all be clear regarding this? Is Q proportional to theta 1 minus theta 2, Q proportional to A, Q proportional to time t in second, and Q inversely proportional to x. Now, so combiningly, what I can write down? Combiningly, I can write down Q proportional to A theta 1 minus theta 2 T by x. So Q is equal to K into A into theta 1 minus theta 2 into T by x. This K is what? This K is what? K is the constant called the thermal conductivity. K is called thermal conductivity. Now I am stopping here. In my next video you will find in my continuation. After that I will discuss